So those lovely FM sounds are from my kind of version of the Awake dual pattern sequencer. So you can find that in the Monome Launch. And I've just done what I think is a reasonable adaptation of it. The difference between this one and, say, some of the other ones that I've been looking at, it uses the FM engine, which I think is a really nice thing. There's also using the mean tone tuning, just gives it a slightly different temperament from the more sort of standard equal temperament. Now, I'm just going to walk through a little bit of the code that's to do with it, but it's a dual pattern sequencer. So essentially what it requires is 2 sequence patterns. So there we have notes, and notes are basically the ones that go through all the time. So if I change notes short to 0, so essentially it's not having any effect on the main output, you should just hear the same recurring pattern. The differences in terms of sounds that we are hearing, so even though we're listening to those notes, what we actually have here is this divisor down at the bottom. So if I code the divisor out, then what we should find is just basically hopefully a static enough sort of sound that will pan. So that's what you can hear there. So this divisor, it's kind of the equivalent of the FM index. And if you've used FM or you've used kind of a modular synth and so on. So the divisor is basically set as a, in this case, it's a ramp. But it could be a ring just as much. I think I had an idea for it to use a ramp, though really in the end I'm just using it as a ring. I think I was exploring what it's like incrementing in sort of like single values and so on. So you have a divisor of 0, so let's have a listen to that first of all. So the divisor has a strong effect on the note outputs, and then what I have here is that it's going to be choose, which means that instead of going in a kind of a linear fashion, so let's try that as a look. So that's what we have there. If it's basically just going from value 1 right the way through, whereas because we have it as choose, it will randomly select from the list. Sometimes there might be duplicates, sometimes there might not. So there's less kind of repetition in terms of events because it's being selected randomly. And that just kind of puts a bit more kind of movement in there. Step 1 here, so a step of a sequence, which is essentially a scale. So the scale we have here is all the way up here, which is Lydian mode. If we wanted to make it major pentatonic, then we can do. We can give it a new name, and then it will play a different scale. If we wanted to have it as the mixo Lydian scale, change that, and then off we go. Now, the thing about the dual pattern sequencers is that in many ways you have to sort of find a really good combination between the scale type and the scale position. So notes here are basically addressing scale position. So scale position, because it's computer starting at 0, scale position 1, which is the second note, 0, the first note, and so on. So that's what we have there. And then added to this is basically the notes short. So it's basically addition. You add, it can be subtraction if we have this note as a negative. So you have 1 plus whatever is here in the notes short. So at the moment it's at 0. So let's say we have two values, 0 and 1. Because they're an even number of steps, 1, 2, 3, 4, 5, 6, 7, 8 for the top row, and then 2 for the add or the shorts row. Essentially, we don't really hear much in the way of variation because they're both of the same. They're both divisible by 2, which means it has a very sort of equal effect. So if I added a third value, so the top row then here is playing has 8 figures or 8 parts to it, and this one has 3. So this should give it a little bit more movement now. And there you go. So that starts to appear there. I'm just going to take the divisor off just for a little bit so that we can just hear the effect of the notes. Of course, these values don't have to be sort of quite low values. We can have them as 12 because up here where I've defined the scale, we've defined the scale that's 3 octaves, which means we've got quite a few notes to select from. So that's the idea. You can hear that really clearly now, especially with the octave jumps. Let's just try one more. Let's do 23. See if there's something in there. No, run out of scale notes, so it's just sort of normalizing itself. Let's try one that is 13. And so we go. So the main sequence of notes essentially refer to scale steps, and then the notes short are then added to whatever the current scale step is, and now that new number becomes the new note that is output. And that code that does that is here. So I've got it with the effects. Let me take the effects off. So I've got a little bit of ping pong delay and a little bit of reverb. So let's code those out. So that's it. That's a dry sound. Now, what I also have are basically two types of tick. Each one is to do with the top and bottom sequencer. So the T here equals tick means the one to do with the live loop, and then this one here is the sequence 2, so it's this kind of note short, so that I'm able to kind of process both at the same time. So therefore the current step becomes whatever is in notes at that current time in time from the tick. And then as long as the current step isn't this kind of rest, so this is the symbol for a rest, and it's so as long as it's not one of those, let's process the notes, because if it's a rest, we actually don't want to hear any notes. That's the idea. So it should be silent. So the add step is whatever is in the note short based on where we are with the T2, this tick here. And then the out step, so the note that we're going to output is basically the current step, which is this one here, plus the add sequence add step. So these two together then become the out step. And that's used to access the my scale, whatever the note value is, and you play it. What I also have is that the pan is basically a random distribution, so it's moving around. So that's the idea. Now, for some of these, I've kind of got some little sort of prepared kind of rings, and I think, okay, let's listen to these different ones. So for quite a few of these, I mean, some of them it sort of says works well with this particular scale mode, like Dorian mode. At the moment, we're in Lydian. So let's have a listen to what this shorts figure sounds like with this ring here. Okay, so let me put the divisor back in. That's kind of one of the shorts. Let's try this one here. The advantage of Sonic Pi's rings is that if you have any numbers that are outside of the number of available kind of scale notes, then the rings will just wrap around, which means that they don't really crash. So unlike an array, which would crash, the ring essentially just wraps around. Even if you're trying to access value 107, it will essentially wrap around based on what 107 would be within the ring that you would have. So that's really good. I mean, it's really helpful, especially when you're sort of trying to kind of play it live and so on. So I'm going to change the main notes to just 3 values, 1, 0, 0, and let the note short kind of carry everything. So we're going to change it to Dorian and take one of the... Actually, let me just code this one out. And uncode that one. There we go. That should work. And again, you know, if you want it to be a little bit higher or in a different octave, you can change the register here. So changing it from C3 to C4. And again, we can change the number of octaves. Let's say we only want it to be over 1 octave. Let's try it as 2 octaves. So, you know, the simple changes can have quite profound effects. Okay, I'm just going to take one off the notes. Let's leave it at 7. So you've got 7 in the top row and 3 in the bottom row. So now it's 7 and 4. Let's do this one and make it 6. 6 and 4. Make it 5. Oh, did I miss something? Yes, I did. There we are. That's what happens when you do it with one hand. Let's make it 5. Here we go. So you can, again, you know, every time we're sort of looking at the different types of notes at the top here, we can also create variations using the divisor. So there are lots of places within it where there are opportunities to create difference. What I really love is when sort of little sort of upper notes sort of suddenly start appearing and then they kind of retreat into the background. enjoyed that, and see you next time.